Well, hi everybody, I'm David. Welcome back to part 3, where we're going to cover inheritance and polymorphism. Time to move on to our third concept, inheritance.
Inheritance is a way to reuse and build on previously coded class designs, and we do this in one of two ways. What you would like to do is develop your mindset into thinking inheritance is purposeful in the two following ways. Firstly, you can inherit the data structure and function from the parent, and you can modify the previous parent class design. Or instead, you can inherit the parent's data structure and functionality, and you can extend that class by adding more code that doesn't exist in the parent class. This will be better explained with an example. To show inheritance in action, we're going to build from the following class structure. The diagram shows that first of all, we're going to build a class called animal. This is going to be our parent class. And then I'm going to show how to descend into two different classes. One that is cat, which is also a type of animal, and a dog, which is also a type of animal. And I want to show in the next slide the two different methods as well for both of these extra designs. We're going to modify the structure from the parent, and we're also going to extend it just so that we've covered all possibilities. So here's the plan for our demonstration. We're going to create a parent class. It's very simple. It's going to be called animal, and it's got very basic behavior. It's got a description of what it does and a screen printout to say what that behavior is. We're then going to develop our design further by using inheritance. We're going to create some child classes, dog and cat, and we're going to show the methods where we can extend cat and we can modify cat, and the same for dog. Firstly, let's build our parent class, animal. What have we got in the code? Well, the first thing we can see, there's actually three things. The first thing is a string, which is going to be the empty box where we can put a description into it. The second item is the constructor. This is actually going to allocate what an animal is to the description that we have. And the third item is a method called myBehavior, and that is, the purpose of that is to print out to the screen what the description is. We're going to extend this for cat and dog shortly. I should also mention that we're using a new word, virtual, and as the slide explains, when you put virtual into the code, it is saying that if you are a child of mine later, you are allowed to modify me. If we didn't put virtual in, the children could not make any changes to that area of code. So there's a little bit of control there with whether you can make changes later or you can't. And we'll show the handshake to this, shall we say, in the descendant classes of how we take advantage of this. So now we're getting onto a child class, and the purpose of this is to modify through inheritance. Now, when you get a child class, it already inherits all of the data structures and methods. You could put no code here and it would be identical to the parent class, but what we're purposefully trying to do is to make a modification. So what we do is we rewrite the behavior method, and what we do is the handshake is to use the word override. This is now telling the code that, okay, we have inherited this method, but what we're now going to do is we're going to make changes as a child. So I put the word override in there, and we've changed up the method so that we have the original description about being an animal, but then eating and sleeping, but then we're also adding the further description to it so that when we ask for this myBehavior and we're a cat, we'll get the full behavior, not just the parent behavior. So you'll get, I think it's I'm an animal, I eat and sleep, and then there's an additional I'm a cat, I'm going to also purr, I think. I can't remember what I put, but yeah, you'll get the idea. Here again, it's the dog code. It's a modification from the pre-existing structure from the parent. We've changed the behavior so that it's not only the description of an animal, but we've added that it's also a dog, and it barks and it fetches throws. Very similar to the cat, basically. Having looked at the demonstration of how to modify a child class, let's have a look at an extension. An extension is basically taking what you've got and just completely adding new methods. So in this example here of the cat, we've added cat trick. This will be a method that only belongs to the cats, and it will basically do a screen printout that says I can climb trees and get out of a garden, and I will show you the dog one very similarly in the next slide. And likewise, here's the dog trick. So we've extended the dog class with an extra method. But what does this all mean? Well, we're slowly building components to build on pre-existing things, to build on other pre-existing things. So we've got building blocks for code. So where would you take it from here? Well, you could quite easily create a kitten class, and if you use the code correctly as shown, you could type in kitten extends cat. What would you have if you created a kitten object? Well, you'd have everything from the animals, you'd have everything from being a cat, and it would also inherit cat trick. So everything would be there. Likewise, if you were to create puppy extended from dog, you would automatically have the animal data and structure, and you'd have the dog data and structure. Even without modifying or extending, the puppy would have a method to do a dog trick. And this is how we can use inheritance to build and build and build more and more and greater complicated objects. And that, my friends, is the point of inheritance.
Let's move on to our last topic, polymorphism. So what's polymorphism? Well, if we take the description of it, polymorphism is the ability of an object to take on many forms. I didn't really find this very helpful at first, so I think it's easier to understand with a few examples, because polymorphism isn't really a difficult topic to understand, and I'll explain it much more easier in the next few slides. What is polymorphism? Well, to me, really, I like to think of polymorphism as the eyes and the ears of object-oriented programming, and I'll explain that in a minute. What can it do? Well, it enables objects to act appropriately according to the type of object it interacts with. You'll see this in the next few demonstrations. Again, polymorphism is the ability of an object to take on many forms. I want to show you two ideas of ways this can be done. Firstly, I want to go on from the inheritance conversation that we had, and we're going to build some hybrid objects. And then after we've done that, I want to show you another way, which is how you can get objects to interact with other objects, and for those objects to act appropriately depending on which object it's working through. This will all become clear in the following examples. Let's go back to our earlier conversation about inheritance. And if you recall, we had a structure where we had a parent class of animal, and then we derived two child classes of both cat and dog. And this slide is just a recap to show how we constructed these items, where we had an animal, we used an animal constructor class, and later on we built a cat to a cat type with a cat constructor class, and so forth. And in the next slide, I want to show you a different idea. How about the idea that if a cat is a type of animal, why don't we try something new? Why don't we build, using a cat constructor, to the original parent, the animal class, the animal type of, And this is demonstrated in this slide, and I want to see where we can go from here next. So as you can see in the next diagram here, we're asking what happens next. Well, what we have is something to build to, and on the left hand side we've got a box and it houses everything that is a type of animal, and the way we built and the way we constructed it in the class design. And in the right hand side of our diagram we have a type of cat. Cat is a descendant of animal, but it also has its own structure. So where do we go from here? We're using a constructor on one side, which is different to the type of on the other side. Let's go back to it visually. What have we got? What is animal type? What is cat type? I've put this next slide up so that we can have a little recap of how we built this in the first place. And what you can see is that the parent class, animal class, had a description as part of its data and a method, my behavior. As we descended down into the cat class, we decided that we would modify a little bit of what we'd inherited, and we thought we would also extend that with a new method, cat trick. So we've got a constructor trying to ram everything it wants to construct into its parent type. I want you to look at these two sides and think, what could possibly happen next to explain what we're about to achieve? Firstly, looking at the boxes, there's just no room for cat trick in the animal box. So firstly, that's got to go. There's no room for it. Cat trick will not exist in this new object that we're building. So what have we done? It's all a bit weird really, isn't it? Well, we have a cat, which is a type of animal, and if we went back to its early description, it's an animal, so it will say I can eat and sleep, but it will also accept the modification that the class constructor can make to the my behavior method. So that was to add more to that description. So we have, I'm an animal, I can eat and sleep, I can also purr and climb trees. That bit of the constructor will go into this new object because the pre-existing data housing was there for it. But what you will not get, which is the weirdness of it, is it's a cat, but it can't do cat trick. So what we've kind of created is a hybrid object, and this is one way I'm trying to demonstrate to you about the ability of an object to take on different forms. I think you'll find the next section on the way objects interact with other objects a little bit more easier to understand, and it's a little bit more in line with what I was saying, that polymorphism is really the eyes and ears of object-oriented programming. Let's move on to those examples. I think they're a bit easier to follow. So here's my first example. It's an object dealing with another object. One of them is an ice cream van. But what the ice cream van needs to do is interact with other objects, and it doesn't always have to be the same object. The clever thing about polymorphism is an ability to recognize another object and treat it differently depending on which object it is. So in this example, we have an object I've created, an ice cream van. What happens is that a certain object approaches my ice cream van. Let's call it a child. It's going to recognize a child, and like any other decent ice cream salesperson, it's going to understand that it's a child, and we're going to offer the child a small ice cream. That's appropriate behavior for this scenario. Now let's try scenario number 2. we have our ice cream van object, and it's going to interact with a different object. It's going to recognize an adult object approaching the ice cream van. So we're not going to offer this person a small ice cream because it's an adult. The appropriate behavior for the ice cream van object is to offer the adult a big ice cream. This is the cleverness of polymorphism. It interacts differently with different objects. Okay, now let's challenge our ice cream van object with another object. Let's have another object called senior adult customer. The ice cream van object is clever enough to recognize a senior adult customer. There will be a method inside ice cream van when passing a senior adult customer to the salesperson would recognize that you would offer big ice creams with senior citizen discounts. You would treat these people differently to the other two scenarios, and that's the greatness of polymorphism. It's clever, it recognizes different objects, and it treats them differently and appropriately. Okay, let's just try another example of polymorphism, just for completeness. This time we're going to have an object that's going to be called toll booth. Now the toll booth has to recognize objects coming towards it and treat it accordingly with different behavior. In the first slide here, we are demonstrating that there is a car object approaching our toll booth and we have to act appropriately. In this case, we're going to charge the car the price of a car crossing for this particular toll booth. Here's the next scenario. We're not going to have a car approaching our toll booth, we're going to have a minivan. Minivan is different. Minivans need to be charged a little bit more for a crossing at this particular toll. So our toll booth is passed, or recognises at least, the minivan, and it charges a little bit more than it did for the car. Lastly, we challenge our toll booth object with an emergency vehicle. When given this object, the toll booth is smart enough to realise it's dealing with an emergency service vehicle. It will know and recognise not to charge anything to the vehicle, but it will also know to open the barrier as soon as possible and let the ambulance, the fire brigade, police or whatever service through in a hurry. Another good example of polymorphism, objects appropriating their behaviour depending on what objects they're dealing with, and that is polymorphism. So that's the end of my video. It's my first YouTube video. I'd like to thank you for watching. I hope you learned something. I certainly did. And well, if you do like anything, as I say, please add some comments, thumbs up, thumbs down, maybe some comments. And yeah, I enjoyed it, and maybe I can do some more stuff.